Alright guys, Arduino tutorial number 9. We're going to make use of the instruction analogWrite now. On Arduino tutorial number 7, we made use of the analogRead function. In this video, we're going to make use of both of them. We're going to take a potentiometer, we're going to look at the voltage from the potentiometer, and we're going to provide ourselves with a proportional output, same voltage as we have coming from the potentiometer going out to the LED. The parts that we require for this guy would be a 10 kilo ohm potentiometer. Again, it doesn't matter the value. I just have a 10 kilo ohm, and that's like a standard value that you'll find in your starter kit. You need a resistor in line with your LED. So I have a 330 ohm resistor. You can make use of a 220, whatever you have in your starter kit. Grab any of the LEDs from your starter kit as well, a yellow, a green, a red. And then it looks like I need 5 different jumpers in order to make this guy work. Let me jump right into the final product here, and then we'll go back to the code, guys. Alright guys, so check this out. This one's really cool. So what we've got is we've got a potentiometer, and this potentiometer, by changing it, will change the 0 to 5 volt signal into the Arduino. The Arduino takes that 0 to 5 and changes it to a 0 to 1023 signal. That value is going into my program, and I've got a little conversion right here because the output is not 0 to 1023. It's 0 to 255. So it does the conversion here and then converts that same proportional voltage out to the LED. So if I have 2.5 volts from my potentiometer here, then I'm going to have 2.5 volts going to my LED. The way that it does this is with pulse width modulation, and by changing this potentiometer, I will change the signal into the Arduino, and watch what happens. Cool, the LED turns on, and you can see that the pulse is coming in. See if I can focus in on the screen here. The pulse is coming in at the same frequency, and what I'm doing now, by changing that signal into the Arduino, I'm going to, well, I'm not going to, but the Arduino is going to change the pulse width to my LED. So as I increase this incoming signal from my pot, then you'll see that the pulse width gets larger and larger, and hopefully you can see the LED is getting brighter and brighter. Cool, eh? I think it's really, really cool. So you can take a scope, whatever type of scope you have at home, and you can connect it up to one side of the LED and the other side of the LED, and you'll see that pulse width going out to it. So it's slowly increasing until we get to the point where we have basically the full 5 volts going to the LED, and that's the brightest we're going to get out of this guy. Cool, eh? The other thing I also wanted to show you was that within this program, we're going to add some stuff in the end, but I also wanted to show you that I'm calling on the serial monitor. So I've got my serial begin 9600 right here, and then I'm printing to the serial print the analog value to the LED. And the output from the Arduino on that pulse width modulation is a 0 to 255 value. So right now we're at the brightest value, so you can see that we've got 255 going out. And as I change the LED, we should be able to monitor the actual value from 0 to 255 that's going out. There you go. So as we reduce that, you can see that the pulse width is reducing, and our value right now we're at 191. Reduce it a little bit longer. Then we got 132, and we'll go all the way down to 0. And at 0, then the LED will cut off and go out. Cool, eh? All right, guys, let's jump into the code and see how to make this work. Before we actually get into the programming, let's go through to our wiring here. So the wiring is similar to the previous video in that we have the potentiometer. Our potentiometer has 5 volts from this pin right here to the outside pin right here. And we're getting that 5 volts from this pin with a positive 5 volts and any ground pin. You can use this ground pin or this ground pin over here. They're both at the same potential. So for simplicity, I've grabbed the 5 volts here between these two terminals, the 5 volts in the ground. They go to the outside terminals of the pot. Then the inside terminal that provides us with that 0 to 5 volt signal is coming down here, and I've tied that into pin A0. So again, down here we have 6 different terminals for the analog in, and I've made use of the first one, A0. For the LED on the output side, I've tied into pin number 3. You'll notice here that there's that squiggly line. I'm not sure what the name of that squiggly line is there, but you will notice that on pins 3, 5, 6, 9, 10, and 11. Each of those guys, you'll see here it says digital and then PWM with the squiggle. So digital outputs are 0, 1, 2, 4, 7, 8, 12, and 13. Those provide either 0 volts or 5 volts. If you want to get that pulse width modulation output, or the simulated 0 to 5 volts output through the pulse width modulation, you're going to have to make use of 3, 5, 6, 9, 10, or 11. So I've made use of number 3. That pulse width modulation is going to go out to my LED. I'm going into my anode here, and my cathode here I have tied in with my 330 ohm resistor, and then from there I'm tying that into ground. Again, the resistor can go in front or behind the LED. It doesn't matter. It's a series circuit there. Just make sure you put some sort of resistance in there so you don't smoke your LED. And once you have all those guys set up, you're ready to rock and roll. Remember from Arduino tutorial number 7 that potentiometer, again, we're providing it with 5 volts as a reference voltage, and depending on where the wiper is or where you're actually turning that knob on the top there, you're going to get either the 5 volts or 0 volts or anything in between. So depending on where this wiper is right here, that determines your potential that's going into your Arduino. Arduino, in this case, Arduino input A0. When we put that 0 to 5 volts into our input A0, then we're making use of the analogRead function. The analogRead function is going to take that 0 to 5 and create a 0 to 1023 integer value. We looked at that again on Arduino video number 7. And if you want a little bit more information on the analogRead, you can go here to this arduino.cc.en reference analogRead. I'll put a link below, and you can get everything you need to know from the analogRead. This one is basically a linear output, and that the 0 to 5 is matching with that 0 to 1023 output. So if we need 1 volt, then we need to, or 1 volt in is going to provide us with 204.6. 2 volts in will give us 409.2. 3, 613.8, 4 is going to give us 818.4, and then finally 5 volts in is going to give us 1023. Okay, in addition to the analogRead, we're also going to make use of the analogWrite. I'll put a link for this page below as well. But everything you need is in the Arduino community. So if you want to know about the analogWrite, you just type in here for the reference, right? And put an analogWrite, and it'll give you everything you need to know about this instruction. So in reading through, it tells us that the output frequency is around 500 hertz. That frequency is going to stay the same, but the Arduino is going to change the width of the pulse that comes out. And if you get more and more width of the pulse, and you're obviously getting more and more voltage gives us more current, and then the LED in this case should get brighter and brighter as that value increases. This one is not a value from 0 to 1023. It's a value from 0 to 255. So that value from 0 to 255 is going to match with the differences in the pulses that are coming out. And that will provide us with that simulated 0 to 5 volt DC output voltage. Okay, so here you can see that we're basically changing what's called the duty cycle, right, between 0, which is off, and 255, which is completely on. Okay, we're making use of the same structure here. Instead of the analogRead, it's analogWrite, so capital W here for the write. Then you're putting in your pin number or the global variable that you created that matches with that pin, and then the value from 0 to 255. And again, we can also create a global variable here, so we can change that on the fly. So this should work the same in that it should be a linear relationship. So if we want 1 volt out, then we'll put a value of 51. If we want 2 volts out, we'll put a value of 102. 3 volts out, 153. 4 volts out, 204. And finally 5 volts for a max of 255. So I believe this is also a linear relationship between the the value that's going out between 0 and 255 and the actual voltage that you'll read on your meter going to the LED. If you'd like a little bit more information on the pulse width modulation, then you can go here to this tutorial. So I'll put this link below as well. And basically, we've already talked about the fact that it's changing the duty cycle to the LED, or the width of the pulse. And the width of the pulse is determining the amount of voltage that's actually going to the load, whether it's an LED or a motor or anything that we're hooking up to this guy. So here we can see that a zero duty cycle will have an analog write with a value of 0. And at that point, nothing's on whatsoever, so we have 0 volts. If we want 25%, well, that's 0.25 of 255. So that gives us a value of 64. And we'll find that the voltage is starting to slowly increase, right? So here we'd have 2.5 volts out, right? So this pulse has now come in and it's starting to increase. If we want 50%, sorry, this would be 1.25. If we want 50% or 2.5 volts, then 0.5 times 255 gives us 127. And you can see that the frequency is staying the same, right? You can see that the period here is always the same in between each of these guys, around 500 hertz for the frequency, but the width of the pulse is increasing. And as the width of the pulse increases, then the voltage increases proportionally. 75% will give us a value, so 0.75 times 255 gives us a value of 191. And that guy is going to give us a proportional voltage output of 3.75 volts. When we want the full 5 volts out, then we'll do a 100% duty cycle. So we'll do analog write and then a value that matches with 255 to provide us with the max voltage out. Okay, so hopefully that clears up the analog read and the analog write. If you want a little bit more information, then go to those links below. Now let's get into the code and let's see how this guy works. All right, so let's get into the code, guys. Let's drop down a few lines here. Let's put a description at the top here. So I called this guy dimmable LED with potentiometer. And what we're making use of is the analog write here. So with analog, come on, Pete. Beautiful. Okay, so once we've got our description in there, I'm going to drop in a few integer values. So the first integer value I'm going to do is for my potentiometer. So on the previous video, I had labeled this as potentiometer. I'm just going to put pot as a short form here. I'm going to have my pot connected into the same Arduino pin. I'm going to have it connected into pot A0. And remember to put your semicolon at the end here. So here we're just declaring the POT, the pot, as Arduino input pin A0. Okay, next integer that I'm going to do is my LED. So I'm sending a signal out to the LED, but I'm going to use an integer value to do that. And I'm going to have that connect up to Arduino pin 3. There are a number of different pins that we can hook up to. Looks like if you're looking at your Arduino, pin 3, 5, 6, 9, 10, and 11 have that little squiggly line there. And that squiggly line is denoting, you'll notice right below it says digital, but then right in brackets it says PWM with that squiggly line. So any terminal that has a squiggly line, 3, 5, 6, 9, 10, and 11 are going to provide us with that pulse width modulation output. So it's a digital signal that will mimic an analog signal that comes out. So for that guy there, we are now declaring the LED as our Arduino output. And I connect it up to my pin number 3. Beautiful. Okay, next thing I'm going to do is I'm going to create an analog read value as an integer value. So that'll be the value that comes from my potentiometer. And what I'm doing is I'm just compressing this again because I'm going to do a picture-in-picture beside here. So right here I'm going to do a picture-in-picture. So normally I would just go right across, but I'm going to compress all my comments here so I have enough room to work with. Okay, so here, using the variable to look at the 0 to 5 volts, potentiometer voltage, at pin, what pin did I connect up to? A0. Beautiful. Okay, in addition to that, I'm also going to make use of the analogWrite value. Okay, so I'm just putting everything in lowercase there, and that guy there, oh, don't forget to put in the semicolons there. Okay, looks good. Here we need a semicolon as well. Beautiful, and we're using this variable to write 0 to 5 volts through that pulse wave modulation to the LED. Sweet. Okay, so that's everything we need in our initial portion here. Within the void setup, and again, remember the void setup runs once and that's it. So I need to do my serial begin, and then I need to do my pin mode for my input and my output. So I'm going to put in first, here, let me put that in line here. I'm going to do serial.begin. And then I'm going to put this at 9600 baud. Okay, then I have my semicolon there. And that is basically it. So we'll put a little comment here that this turns on the serial port at 9600 baud. Beautiful. Okay, come on. Next thing we're going to do is pin mode. So pin mode is PIN, capital M-O-D-E. And for the first guy above, I've created that integer pot, right? So I'm going to create pot, and I'm going to say that pot is going to act as an input. And you'll see that this has to match. So I've got my pot as all caps here. So if they were all lowercase, I'd keep it all lowercase. It has to be exactly the same as this value that I have above. And you notice that the input is all capitals as well. Close that guy, put a semicolon, and we are done. And we also have to set the pin mode. And we're going to set the pin mode for this LED above. So I've got that as capitals above, so I'll keep it the same. And then again, keeping the caps lock on, I'm putting output, close the brackets, semicolon, and we are done with the void setup. Within the void loop, remember the void loop runs over and over and over. The first thing I'm going to do here is I'm going to say that my analogRead value, which is the value up here that I created as an integer value, is going to be equal to analogRead. And we did this on the previous video. Looks good. Everything's orange there. And we're going to look at the value on the pot, on the potentiometer. There we go. Looks good. So, and we'll put a comment below. This reads the value from the potentiometer. Looks good. Let's put these comments in a touch, and then we can see that they're separate from the actual code. Looks good. Okay, so I'm saying that my analogRead value is equal to my analogRead, and what is it reading? It's reading that pot value, that potentiometer value. And then the next thing I'm going to do is my analogWrite. So this is the key thing for this video. So we're going to make use of the analogWrite value. Again, that analogWrite value is just an integer that I made right here. And that analogWrite value is going to be equal to the ratio of 255, so 255. I'm going to put a decimal place there, right? Because remember, the decimal place allows me to have a floating value. And I'm going to have the ratio between my 255 value and my 1023 value. There we go. So that'll provide us with a proportional output. And what are we going to multiply that ratio by? We're going to multiply that by our analogRead value. Sweet. Okay, so we'll just put in a comment below. This line does the conversion from the 1023 scale that we have on the analog read to the 0 to 255 scale that we have on the analog write. Beauty. Okay, next thing we're going to do is the analog write. And where are we going to write to? We're going to write the LED, right? So to the LED, we're going to provide it with the analog write value. So that'll provide us with the signal of 0 to 255 to the LED, right? The analog write value is an integer. My LED value is also an integer as well. Okay, then I'd also like to make use of the serial print. So I'm just going to write in serial.print, and I'm going to put this in quotations now. So this value will always come up. Analog value, come on, to the LED. And I'll put this, and then I'm going to put a space there as well so that I don't have the value right up against that colon there. And then quotes, and then close the brackets, and then a semicolon. So that will write analog value to the LED, then it'll hit a space, and then we'll do a serial.print line, and that value will be equal to the analog write value. Beautiful. Okay, before it loops back up to the top, let's put in a delay, and we'll put in a delay of 500 milliseconds. Beautiful. Everything looks good. Okay, so let's verify this guy. And when I verify it, it's going to ask me to save this, so I'll just save this and then come back to you. Beauty, so it's just compiling the sketch. Everything's done. Everything looks cool. And now let's send this over to Arduino now. Okay, so let's upload this to Arduino. Beauty, looks good. Everything's cool. Let's open up our serial monitor. And we can see here that the value to the LED is 0, from that 0 to 255. We obviously have no light coming out of the LED, and we've got no pulses, and we can see that the voltage here is nothing as well. What I'm going to do now is I'm going to increase the signal into the Arduino, and I'm going to get an output of around 51. When we get to around 51, you can see those pulses coming in there. There we go. We should have 1 volt output here. Beautiful. So 0.97 volts output. Looks good. Okay, let's increase the signal into the Arduino and get an proportional signal out. So we're going to go to 102 now. So we're increasing here to 102. Beautiful. And we should see something close to 2 volts out there. Okay, so I got 1.89. Maybe just that it's not making contact there. But that's pretty close there for the 2 volts output there. Then we're going to 153. 153 should match with a voltage of 3 volts. So again, we're increasing it to 153. And there we should get roughly 3 volts out. I got 2.89. Okay, and 4 volts should be a value of 204. There we go. So there's 203, 204. And again, there's our value of 3.84. Okay, and then if we increase to 255, we should get the full 5 volts out. So we'll increase here to, come on, 255. Beautiful. And at that point, so you can see there that I'm not, the reason why the other values are lower is again because I'm only getting 4.85 as my max voltage out for some reason there. Okay, so it should give you a proportional value from 0 all the way up to whatever the max voltage is you're getting out of your USB there. If you had 5 volts available on the USB, then obviously this value right here would be 5 volts. But it's pretty cool, eh? You're able to change that width of the pulse, and by changing the width of the pulse, you're changing the voltage that's going out to your LED. Cool, eh? All right, so next thing we need to do is on the serial monitor, we can see the value that's going out to the LED, but we'd also like to keep track of the voltage that's matching with that value and hopefully mimicking on the meter here. So let's put in a little bit more code and we'll finish this video off. Okay, so what we're going to do is we're going to add in a value above, so before our void setup. We've been using integers before, but integers are whole numbers, and we want to have the decimal place for the voltage. So we're going to create a float. So again, you can see that it goes blue. Okay, everything's in lowercase there. And I'm going to create a global variable called voltage that's going to match with that float. That value as a float will then be able to provide me with that decimal place output. Okay, down here we had our analog voltage value to the LED, and then we had, and we did the serial print line, and then we wrote our analogWrite value. Then we had a delay, and then right below there we're going to put in our voltage value. So matching here with this global variable that we have here is going to be equal to, we have to do a conversion. Remember that we have 255 as our maximum output. That 255 is going to match with 5 volts. So we're going to do the ratio of 5 volts out of 255. Again, you'll see that I'm using a decimal place so I can get a float value. And then we're going to multiply that by our analogRrite value. Okay, so I'm gonna multiply that ratio so I can change the 0 to 255 to now a 0 to 5 volt ratio. Now we're gonna have the analogWrite being multiplied by that analogWrite value multiplied by that ratio there, and again, don't forget your semicolon. Beautiful. Then we're gonna print that to the serial monitor. So then we're doing capital S serial.print. And let's see, we'll do print line, and then we'll say voltage, serial print, and we're going to say in quotations that the analog voltage to the LED, and we'll put a space here, so just to give it some space before that value actually comes in. Close that, semicolon, and then below we'll do the serial print line. Print line, and then we'll put in our voltage value. So again, we're going to put in our global variable voltage that was determined above. And again, before we go back up to the top, let's put in another delay of 500 milliseconds. Looks good. Let's make sure that we scroll down and make sure that we haven't lost the parentheses. So again, we can hover here and it shows us that we closed that guy up. Okay, let's verify that guy again. Okay, looks good. And let's download that to our Arduino and see how that changes things. Okay, so we're uploading to the Arduino. Sweet, looks good. Okay, by changing that potentiometer, I should still be able to, because nothing else has changed in the code there, so I should still be able to change the pulse width there. Looks good. And now when I open up my serial monitor, what have we got? Beautiful. Okay, so we can see there that the value to the output there from 0 to 255 is being displayed, and then the expected voltage is there as well. So right now we're putting out a value of 157, expecting a voltage of 3.08, and I'm getting 2.99 on my meter. As I change that value on my pot, then I should have a proportional value that comes out of my Arduino there. I'm expecting a value of 2.02 now, and I've got a value of 1.96. Beautiful. Cool, eh? So now we can keep track of the output value. We can look at the voltage. And if we reduce this down, we're expecting a value of 0.8 volts here. Here I got 0.77, 0.78, right? So really cool how you can take a little bit of code and now gather a lot of information on the circuit that you've now hooked up, right? So we'll increase the value into the Arduino, which is increasing our value out. We're looking for a value of 3.96. I've lost this meter lead there. And again, I got 3.85 as my output there. So I'm a little bit off in that my max voltage coming out of my USB is frustratingly not 5 volts today. I'm getting a max voltage of, come on, buddy. I'm getting a max voltage of 4.86, so I'm a little bit off with the values that we're seeing on the serial monitor. But if you were getting 5 volts out of your USB, then they would match perfectly. All right, guys. Hopefully everything made sense. This is pretty cool. We've now got a signal going into the Arduino, and we're now providing a proportional output in that the same voltage that's going into the Arduino is now going out of the Arduino. We've made use of the analogRead value, now the analogWrite value, and we're now able to look at signals coming into the Arduino and then provide a signal out using that pulse width modulation. All right, guys, thanks for watching. We'll see you on the next video.